Okay. Think we should all be here. All right. First, I'd like to thank everyone for coming out tonight and joining us for Bettina leading a very interesting topic about how she used NLP to evaluate whether or not a question would be answered on Stack Overflow. Always a question at the top of everyone's mind when they have the courage to post a question to Stack Overflow. My name is Alex Antonison. I am the organizer of Data Nerds. With us is Bettina. She is an NSS data science grad, and she has recently accepted a data science job. So congrats to her. Without further ado, I'm going to kick it over to Bettina. One last thing. Because it is difficult to have multiple people talking at once, if you have any questions throughout the meetup, please post them to the chat, and I will be watching it and I will be moderating. So as Bettina hits a good kind of mid-stopping point, I will gently kind of notify her that we have a couple questions, and that's how we can kind of manage that. Towards the end, we will, have a little bit more free-flowing discussion, but still posting directly to the chat so I can kind of moderate. Okay. All yours.
Sounds great. Thank you for joining, everyone, and thank you, Alex, for letting me share a little bit about my capstone project on Stack Overflow. And just FYI, if you have questions, of course, feel free to ask in the chat. But you can also go and just contact me on LinkedIn. There is only one Bettina Kozissnik there. And so, yeah, just feel free. And then all my code is on GitHub as well. So with more resources and so on. So let's get straight into it. Stack Overflow is an incredible resource, especially if you're starting out fresh in pretty much any new programming language. And when you finally have figured out how to properly phrase your problem, then yes, Stack Overflow is definitely a fantastic resource to get an answer. And so for my capstone project, I knew I wanted to play around with natural language processing. And I thought, hey, what better place than Stack Overflow? And I wanted to do an analysis specifically like towards data science and data analytics. And just to look a bit into that. And what I'm showing you here is actually a little dashboard that I created just for the analytics portion of my capstone. It's an R-Shiny dashboard. Again, code is all on GitHub. And so one of the first things that I wanted to see is what have been the trends with the different programming languages over the last couple of years. And like with regard to the most popular tags on Stack Overflow, you can see that Python is just rocking it out right there. And that Java and JavaScript seem to have a little renaissance going at the moment. And when we look closer into the Python packages, we see that pandas, of course, as primary tool for anybody doing data analytics with Python, is really taking it away. And then interestingly, also Django is seeing quite a rise. And then obviously other things like TensorFlow, very hip at the moment. With regard to, so I also looked into machine learning tags, and there TensorFlow just takes it away. But what was interesting here is, though not really correlated, but in terms of appearance, deep learning and scikit-learn seems to be almost synonymous with regard to the tag count. And then lastly, I was particularly interested in the most popular web service tags. And there I found it particularly interesting that the Google Firestore only popped up in 2017, while Azure, yeah, definitely a little longer. And then AWS is just, yeah, really kicking it off. Then back to the natural language processing. So as I said, I just wanted to have fun and see a couple of things that I can pull out of the data that I scraped from StackOverflow. And so I did a little topic modeling on the 3 most popular programming languages for data analysts, data scientists, so Python, SQL, and R. And just had a look, and you can play around yourself on the different topics. I also did a little bigram, trigram analysis. And it was quite interesting to see what combinations came out of that. Like, for example, file handling in Python seems to be a popular topic. And then here you see the combination file use Python. Also interesting was use Selenium Python. And then lists, big topic, and list of lists. Of course, keep in mind, I took out some words and cleaned my questions before I put them in. SQL Server is an extremely big topic. And yeah, so feel free to explore also with regard to R. Now, as with regard to how I got to this data, and then also did some machine learning, I decided, so if you go on StackOverflow, you can look at the newest questions, active questions. And another thing that you can look at is the hot questions, so the best voted questions. And I decided to use these questions with the highest number of votes, so they would not outpace my scraper, because per second there's about 100,000 questions that are submitted to StackOverflow, and that would have simply overwhelmed my scraper. So I decided to work my way back from the highest voted quotes. How that works is, so you have the highest voted questions, and then it works itself back in time through the other questions that actually are left on StackOverflow. And yeah, that was quite neat. So how I did that, here's a quick Jupyter notebook to give you an idea. So I used Beautiful Soup in combination with requests. And yeah, Beautiful Soup is, if you need to do any web scraping, it's just a really, really nice tool, because you can really tailor your code to pick out specific HTML elements. Yeah, of course, you also get to learn a bit of HTML structure if you're not familiar with that. But as you can see, like, it was really easy for me, for example, to pick out user, and then I had to fix some use cases. where, for example, some of the questions on Stack Overflow are tagged as community wiki, and then suddenly they don't have a date time tag associated with it, or they are anonymous. That is when a user on Stack Overflow just left the platform, like their questions not necessarily disappear, especially if they are highly voted questions. But again, without date and time. So I had to fix that and adjust my code accordingly. Please feel free to dive in as much as you want. And then, of course, combining everything in my scraper after I worked out all these kinks. And then just letting it run. It took me a week. My computer only has 16 gigabyte RAM, and it's really worked 24 hours for 7 days, but I got 22 million questions. So I was really happy about that. The second part of the scraper was really, so 1A was basically scraping one site at the time. But if you look on the highest quoted question, you have about 50 questions per site. So you want to make sure that it automatically goes to the next 50 questions and so on and so forth, and saves in between, so that, and also keeps a record of any errors that occur. So that you can go back and either restart the scraper at a certain point or fix those errors and so on. So that's basically what this second scraper is. Right here, sorry. Yeah, you can see, like, this is, for example, the last time that it got stuck. So I reran it and yep. Now, once I got all my data together, there was quite a bit of data cleaning to be done. And I know I committed a really bad sin here in importing pretty much any library that I could think of with regard to natural language processing. But this is also as a personal reference. So if you really want to dig into natural language processing, check out NLTK, check out GenSim. SpaCy has really, really good documentation. And for example, the topic modeling that you saw and these nice interactive HTML objects that I had in my RShiny dashboard, they are courtesy of PyLDA Avis and so on and so forth. And so here, my big file, then cleaning up, removing, just putting everything lowercase, removing special characters, and so forth. You can see how it changes. And then lemmatization. Here you have the code for my bigrams and trigrams. So if you go down here, you actually see what we saw before, just this time as not as a Plotly chart. Yeah, and then obviously with much longer. And then last but not least, I really like word clouds, and you saw that actually on the title page of my dashboard. And so, yeah, that's here. It shows you also how to put that together yourself. And now on the topic modeling.
Hey, Bettina, real quick.
Yeah.
There was a question from Scott asking, was there a specific reason why you went with a web scraping approach versus using the Stack Overflow API?
That's actually a good question. I honestly did not think about that. I was just so used to, my other project was Boston Marathon data, which I also had to scrape. So I was just like, oh, as a nice exercise, I can just design my own web scraper. But yeah, going forward, I would use the API.
Oh no, absolutely. I've personally done that a lot myself, where not checking for APIs, but also when scraping. Just to throw out there, a lot of websites do have policies on scraping. So, and sometimes in those policies, it'll specify that you should instead use their API. Because sometimes if a lot of people scrape, it can be a bit of a burden on the website. So, anywho, okay, that was it.
Sounds good. So to get a little into the topic modeling, again, my already cleaned up text, we're getting the stop words, like getting a real nice corpus together, and then applying the modeling. You see on the runtime, again, keep in mind that building the LDA model and then building the visualization. Like you see on my computer, it took 14 minutes to build the model. Of course, if you spin that up into the cloud, you can do that much faster, but just FYI, that it might take a bit. And actually this runtime specifically had me really excited once I figured out how to just export this nice interactive chart into as an HTML object and paste it as such into my RShiny dashboard to really let users play around with the different topics and what words were summarized in the topics. And yeah, and I have, this is the Python specific topic model. There's also notebooks on my GitHub for SQL and R. And then I also did a little, since as a data scientist, you want to do something predictive as well. I figured I'm gonna do a really simple NLP model. So please don't beat me. And how I did that. So I wanted to see whether I could predict if a question on Stack Overflow gets answered or not. And then potentially, if I could, also show you which words to avoid, like how to phrase your question a bit so the probability that it receives an answer is much higher. And this is what this model aims for. And so very basic, you have your train test split with sklearn, and then I used the vectorizer and logistic regression. I did a lot of different combinations to see whether I could improve my model. But I found out that this was what worked best. And you can see I have quite an imbalanced data set in terms of that. I don't know if I actually have it here. So I have 16 million answers, like questions with answers, but only about 14 million of those, 14 million of those received answers. And so about 2 million did not receive answers. So that made it quite imbalanced. So about 18, 19% of questions did not get answered. So when we look at the classification report, you see that issue as well in the precision. So my model is, of course, since it's trained on a very imbalanced data set, much better at giving you an answer, how to get an answer on Stack Overflow. But rather than telling you what to avoid, but the recall was 62%, so I was overall okay to try a text explainer. And I used Lime. If you want to show off like what your model, how your model works, I would really recommend looking into Lime. The documentation is not so straightforward, but once you figured it out a bit, like there's all sorts of cool explaining tools under Lime. And yeah, here I built this tiny widget where you can put in a question and get and see what the probability is according to my very simple model that you will receive or will not receive an answer on Stack Overflow. And the question that I typed in just for demo purposes was, how can I combine sparse matrices in Python? And I'm not sure how good it shows up in Zoom, but you see that the combine word, funnily enough, seemed to tilt the probability at least a tiny bit towards getting an answer, while the use of sparse and Python do not really help my case. And then last but not least, so I tried to develop my own features, and sort of the reason for the question, how do I combine sparse matrices? If you're trying like me to combine your original sets and expand them, like tag on, to like if you use a vectorizer, then basically your table is going to contain a lot of zeros, and so it's just more efficient to be saved as a sparse matrix. But that also makes the problem, so whatever features you produce, you also want to convert into a sparse matrix in order to merge it onto your data set and use it. So that's where that came from, and you have all the documentation on here as well. And then last but not least, I mentioned that it's a very imbalanced data set. And actually here you see on the value counts how imbalanced it really is. So yeah, that's about 18%. I just did, again, just playing around, having fun, decided to just upsample my missing answers. And so that's how I end up with that. And then run a model. And funnily enough, my accuracy score actually dropped. And my recall, yeah, looks a bit, my precision, of course, now biased towards getting no answer. And if I put in the same question that I put into my other imbalanced, like model with the imbalanced data, you see that it's slightly different outcome. Not really massive, just a little slight. Yeah. Any questions?
I have a kind of silly questions. So, can you hear me?
Yes.
Yeah. You mentioned that you selected questions that is mostly voted, right?
Yes, I did.
But I wonder why when you select most voted questions, so many of them are not answered?
Actually, no, the way it works on Stack Overflow, so every minute, like people post question, and some of the question, especially if they are simple, like for example, what is a good tutorial on Python, or how do I import the pandas library, will automatically by the community, like there's administrators on there that will downvote those, so they get removed. And so the voted questions are questions that are interesting to the community. And so it's basically mostly stuff that's not covered in basic tutorials and so on. And also the fresh questions that come in, if you monitor that feed for a while, it's a lot of the same questions that come up. So that was another reason why I went with the most voted. And you're correct, even under the most voted questions, like it drops off rather quickly after just a couple of thousand questions where they have no votes, but they have answers and so on. And then I actually, like one of the fields in my, if you look at my scraper and then also the table that resulted from it, there is number of answers to the questions as well. So
okay.
that's, yeah, that was the reason behind it.
Yeah, another question. You said, you mentioned you take a week to run the program?
The scraper, to scrape the 22 million questions and answers. Yes, it took my computer a week.
Get the data, it took like a week. You mean just to get the data to be analyzed, it took about a week? That's scraping. Wow. Okay. That takes a long time. Yeah. So
yeah, but it was, as I said, like that was all local on my machine. Practically, I should have used a cloud-based service and just like, for example, AWS has a free tier. And
why it takes so long time to scrape the website? Like it's only 24 million records, right?
Yes, the limitation is more in the computing power of my computer. I used the 2012 MacBook Pro with just 16 gigabyte RAM. And so, yeah.
Okay. Thanks. It's a great work. Yeah, it's a lot of work that you have done. Yeah.
But as I said, like, please check out my notebooks and just have fun and explore on your own. And yeah.
Hey, Betty Ann, you had a really good comment about model interpretation. Do you want to, I know you mentioned in the chat, but do you want to talk about that a little bit more as a group?
Who, me, Betty Ann, or Bettina?
Betty Ann.
Okay, I wanted to be sure I heard that correctly. Yeah, thanks, Alex. So somebody in the chat, I think it was Scott, mentioned that he hadn't heard of Lime before. And I just wanted to mention that Lime can help you understand importance, feature importance, and how they balance for a particular case or a particular row or a particular, I'm in healthcare, so for a particular patient, or in Bettina's case, a particular question. It doesn't really talk too much about the model as a whole. If you want to understand your model, not just on a case-by-case basis, you might look at the SHAP library, which is based on Shapley values. And I have to admit that the plots that come out of SHAP are lovely and beautiful, but it takes me a while to wrap my head around it. But it's a pretty neat measure, and it's a nice plot to look at. And actually, Bettina, may I ask you a question? That you said you upsampled your data. Did you just upsample it by duplicating, or did you upsample using, say, some kind of algorithm like SMOTE or anything?
I actually did not dig too much into SMOTE and those options. The upsampling that I did was via the scikit-learn utilities. It actually has a here. Let me share that real quick. It actually has this resample function.
Right.
So that's what I used.
Right.
And you're absolutely correct. A tree-based model would have most likely been the better approach.
Oh, I don't know if it would be better, but it certainly is something to explore, especially with unbalanced data. And my other comment about SMOTE is I have to say that I've never been particularly successful using SMOTE because it seems to, the interpolation that it does to make up synthetic records, I can understand how that works with continuous data. I don't really understand how it works with categorical. In fact, I don't think it does deal with categorical data. So I often have categorical data. So SMOTE just doesn't work for me. And I would imagine now that I think through it more, that may be the case for text. I mean, how would it make up data?
Yeah, I was wondering about the same thing, to be honest. But in general, actually, that would be an idea for another talk, how to deal with different kinds of imbalanced data.
Yeah. Although, you know, just off the top of my head, and I wonder what you all think, I could imagine that SMOTE might be able to interpolate words if it had its vector neighbors and understood what words were, you know, highly related. So then, you know, it could, so say, you know, my question, the real question has dog in it. And instead of using dog, it might use something like, I don't know, pick something close to dogs, wolves or something. But it would have to have the vectorization of all those words. And so I'm just kind of thinking off the top of my head, clearly that, you know, somebody should write that.
In the chat, it looks like Matthew also has an interesting suggestion. Matthew, can I call you out?
Sure, I'm also cooking, so sorry if there's noise in the background. But yeah, on a kind of non-text related project, I started dabbling in Markov chains, which look at the probability, well, in the first order Markov chains, just look at the probability of any given word in your corpus following another. And you can use it, you know, with, once you've trained it on a data set, to synthesize text that reflects what it's been trained on. So not necessarily stuff that makes sense, but it's kind of fun to kind of play around with. I think it might be what people used in early, you know, chatbots or bots on Reddit that go around making semi-human looking posts to other people.
Any other questions or comments?
This is Betty Ann again. My most immediate comment is, Bettina, very nice job. Thank you for sharing this with us. And it's really nice to see, you know, all the skills that you bring to this, and that you ask kind of fun, interesting questions that you went after and tackled. So very nice job. Thank you.
Thank you.
Awesome. Well, it sounds like we've had a really good meetup. Thank you, Bettina, for taking the time to share this with us and answering our questions. As always, I've included Bettina's information in the meetup, so feel free to always reach out to her. you know, I'll be posting, like always, this will be recorded. So I'll be posting that. I'll be posting links to the GitHub where she's hosted the code, as well as her information. Again, that should be coming out in the next few days. And yeah, thank you, everyone. Hope everyone has a good night. Bye.
Thank you, everybody.